Hello and welcome to A Level Math. This topic is about functions. In the previous videos, we have covered the ideas of sets and relations. So, functions are nothing but special types of relations. So, for understanding functions, make sure that you're already familiar with the concepts of relations because functions are nothing but relations but some special properties. So, let's first look at the definition of function. Assume that we are given two sets, x and y. Then a function is a relation from x to y such that every element in x has a unique image in y. So you have to make sure that you remember three things. First thing, that functions are actually a relation. The second thing is this word every. It says that every element in x has to have a unique image in y. So you have to make sure that you are understanding these two words very carefully. First, every element in X. Second, a unique image in Y. So you remember how we understood relations with the help of arrow diagrams? Suppose this is the set X and this is the set Y. Assume that there are three elements in X, 1, 2 and 3, and each of these elements go to some image in Y. So these points in Y are actually called the images of X. So these points could be 5, 6, 7 and 8. So suppose that 1 goes to 5, 2 goes to 6 and 3 goes to 7 and 8 has no pre-image. So these points here are called pre-images and these points over here are called the images of X under F. Okay, so the relation would be defined something like this: 1 comma 5, 2 comma 6 and 3 comma 7. So this relation has to have three properties. Okay, so not three, in this case two, because we are already assuming that it is a relation. So this relation, if this relation has two more properties in it, these two words every and unique, then it will be a function. So let's understand what do we mean by every element in X. So the relation, if these elements are all the elements that are there in X, that means X should not be having any more than these elements. And secondly, for every element in X, say for example 1, there cannot be more than one image. So say for example, if 1 is going to 5, then 1 cannot go to any other image, say 8. If it goes, then this relation will not be a function. So a function is actually a relation where two things have to satisfy. First, that every element in X, each of these elements 1, 2 and 3 has to have a pre-image. So 1, 2 and 3, all of these 3 points has to have an image, sorry, not a pre-image, has to have an image. And secondly, this image has to be unique. That means if one of the elements, say for example 2, is going to some element, say 6, then 2 cannot go to some other image, say 5. Okay, I hope this is clear. If not, let's take up one more example. So there are three relations that are given to you. Now you have to tell me which of these relations is a function and which are not. So let's try to understand this. The first one, f, is given by 1 comma 3, 1 comma 5, 2 comma 3 and 2 comma 5. So this relation is not a function because you see 1 is going to 3 as well as 1 is going to 5. So this one is not having a unique image in y. So this f is not a relation, this f is not a function. It is definitely a relation because it is a subset of some ordered pair, but f is not a function. It is just a relation and not a function. Okay, let's come to question number G. That means question number 2, the relation G. Relation G is given by 2 comma 1, 5 comma 1, 8 comma 1 and 11 comma 1. Okay, so there are many points going to 1. That is valid. I didn't say that many points cannot go to a single image. That can be possible. The only requirement is that one point cannot go to multiple images. So that means something like this is valid. Many points going to one point is valid. Just like here is the case, 2, 5, 8, all of these are going to 1, even 11 as well. So this is valid, many points going to one point. But what is not valid is this. One point going to multiple points. Say for example, 1 is going to 5, 6 and 7. This is not valid. So this is not a function. So this is actually a function. This is valid because this is something like this case. Okay. So G is actually a function. G is a function. Now let's move on to question number 3, H. So here we are having 2 comma 1, 4 comma 2, 6 comma 3, 8 comma 4, 10 comma 5 and 12 comma 6. So do you think this is a function? Yes, of course, because here as well we are not having multiple images for one single point. So this is a function as well. So F is not a function, but G and H are actually functions. Okay. Let A be a set given by -2, -1, 0, 1 and 2 and F be a function from A to Z. This is the denote. This is how we denote a function. We read it as a function from A to Z. That means it will be taking some points from A and taking them to the set Z as images. All right. So this is how we read a function. A function from A to Z means we'll be having our set A over here and our say Z over here, and the function will take every point from A to the set Z. All right. So there are 5 points in here: -2, -1, 0, 1 and 2, and Z is something that we need to figure out. So we are given this relation that fx is this. That means every point x goes to this particular set. I mean, if we want to find out where is f of -2 going, that means where is -2 actually going, what you just do, you substitute -2 in place of x. So f of -2 will be -2 the whole squared -2 times -2 -3. So what I have done is just put -2 in place of x and simplify. So we'll be having 4 plus 4 minus 3, which is 8 minus 3, which is 5. So -2 goes to 5. Alright. Now where does -1 go? F of -1 is equal to -1 squared -2 times -1 minus 3, which is equal to 1 plus 2 minus 3, which is equal to 0. Similarly, f of 0 goes to -3. F of 1 goes to 1 minus 5, which is -4. I'm just writing down the answers, but you must verify yourself. And f of 2 is equal to 4 minus 4, 0 minus 3. Okay. So we can have the images of all of these points in A in Z. Okay. So what is the range of f? Range is again, as we mentioned in the relations, range is all those right hand side points. So that means if we are to write down this function f, then f can be written as -2 comma 5, -1 comma -3, then 0 comma -3, 1 comma -4 and 2 comma -3. Sorry, -1 goes to 0. Alright, So these points minus 2, minus 1, 0, 1 and 2 form the domain. That means the domain is nothing but the set A. This is our domain, and range is nothing but these points 5, 0, minus 3, minus 4 and minus 3. So our range of f is actually the set of all these values that are attained by the function. So the range is the set of all those values which are attained by the function. So this is 5, then 0, then minus 3 and minus 4. Remember, repetition is not allowed inside a set, so we don't write minus 3 twice. Now what are pre-images of 6? Okay, so it asks you what are the pre-images of 6. So to figure out what are the pre-images of 6, what we need to do, we just need to find out that value of x for which the image is 6. That is the meaning of a pre-image of 6. That means 6 is some image, and we need to find out its corresponding pre-image. You remember I told you that all the elements that belong in here are called the pre-images, and all the elements that belong in here are called the images. So we are given a value 6, and if we are to find out its pre-image, then we have to find out that value of x which will give us 6. So just like this 5 has the pre-image minus 2, similarly there is somewhere 6 over here, and we need to find out the corresponding pre-image of it. So how we do, we just find out what value of x gives us 6. Okay, so we just solve it. X squared minus 2x minus 3 minus 6 is equal to 0. X squared minus 2x minus 9 is equal to 0. So we cannot factorize it. So what we do, we use the formula x is equal to minus b plus minus root over b squared minus 4 times a times c whole divided by 2 times a. So if you're not familiar with this formula, it's okay. You will be learning about it when you learn the chapter quadratic equations. So the formula that I have used is this: x is equal to minus b plus minus root over b squared minus 4ac whole divided by 2a. This is the formula, and when you will be familiar with it, you won't be finding any trouble in solving these kinds of quadratic equations. So I'll just solve it. 2 plus minus root over 4 plus 36 whole divided by 2, which is 2 plus minus root over 40 whole divided by 2, and clearly this is something irrational, so this is actually an irrational number. And so it cannot belong to a. So it doesn't belong to a. That means 6 has no pre-image in a, because a is only having these elements. So our 6, the pre-image of 6 was required to be one of these elements, but this is actually an irrational number, and this doesn't belong to a. So 6 has no pre-image in a. Similarly, if you want to find out the pre-images of minus 3 and 5, just equate them to x square minus 2x minus 3 and try to find out the values of x. If x is one of these elements, minus 2, minus 1, 0, 1 and 2, then you conclude that okay, minus 3 has this pre-image. And if you do not find that element in a, just conclude that okay, minus 3 has no pre-image in a. That's it. Okay, now equality of two functions. Suppose you are given two functions. One function is f and the other function is g. So when do you think these two functions will be equal? Okay, so for the equality of two functions, we need that they behave in exactly the same way. That means if you take one particular point and it is going to say 3, then under g as well it should go to 3. If you are taking some other point, say for example 5, and it is going to 7 under f, then under g as well this 5 should go to 7. Alright, So this should happen for all the points. Okay, so that means fx should be equal to gx for all x, for all x. And where do we take x from? We take x from the domain, right? The left hand side part, the a that was there in the previous case, so that's actually the domain for all x belonging to the domain. All right, so this is the very important, the most important thing that you need for the equality of two functions, that fx should be equal to gx for all x belonging to the domain. And also we need to have the same domains and same codomains for both of these functions. So there are three requirements. First requirement for the equality of two functions is that their domains are same. Second condition is that their codomains should be same. And third condition is that this thing must hold, fx equal to gx for all x belonging to the domain, whatever is the domain, it should be common in them. So whatever x you take from that domain, fx is equal to gx. That means the images under both f and g are actually equal. So let's figure out whether this particular example gives us an example of equality of two functions or not. It clearly says that f and g are not equal. So we need to show that these two functions, first one is this and the second one is this, are not equal. These two functions are not equal. So remember what were the three conditions? The first condition was that their domains should be the same. But here if you look, I told you, remember that the left hand side set is called actually the domain. So here the domain is the entire real line. For f, the domain is the entire real line. And for g, the domain is the entire real line set but excluding 2. So for the set g, domain is r minus 2. Alright, and this is quite obvious as well, because you remember that denominators cannot have 0. Any fraction cannot have 0 as its denominator. So the domain has to be all of the real numbers excluding 2, because if you try to find out g of 2, what you will be getting is 2 square minus 4 by 2 minus 2, which will give you a 0 in the denominator. That is why 2 cannot belong to the domain, because if it would have been in the domain, then you remember I told you what is the function, what is the definition of a function, that for every point in the domain there has to be some image, but corresponding to 2 we are not having any image. That means 2 cannot belong to the domain, right? So that is why we have to exclude 2 from the domain, because for a function, for every points in the domain, the function has to be defined. It cannot give you undefined values for any point in the domain. Okay, so the fact that these two domains are not equal gives us the result that f is not actually equal to g. Okay, so now the question asks you, how would you define f and g such that both of them become equal? That means it says that okay, you can make some little changes in either f or g, whatever you wish, but the aim is that you want f and g to be exactly the same functions. Okay, so observe that gx is given to you like this. Okay, so what you do, you can factorize the numerator as x plus 2 times x minus 2 divided by x minus 2, and you can cancel out x minus 2 and x minus 2 on the condition that x minus 2 is not equal to 0. Remember, you are a grown-up kid now because you are no longer in class 10th. So initially what you did, whenever you saw the same thing in the numerator and the denominator, you used to cancel it out. But remember, from now on, whenever you are making some cancellations from the numerator and the denominator, make sure that it cannot be equal. So you have to supply a reasoning that if we assume that x minus 2 is not 0, then and only then we can cancel x minus 2 from the numerator and the denominator. Always make sure that you have to keep this thing in mind because you are grown up now. So remember, 0 and 0 can never cancel each other. So whenever you are cancel something, just make sure that you are writing it down that we assume x minus 2 is not 0. So gx will be equal to x plus 2 when x minus 2 is not 0. That means when x is not equal to 2. Alright, we can take minus 2 on the other side. So that will give us x not equal to 2. Alright, so we get that gx is equal to x plus 2 whenever x is not equal to 2. So that means if you take any value of x except for 2, this gx will be equal to x plus 2, which is nothing but the value of fx. Right? So that means gx and fx are actually the same functions, except that fx has a value 4 at x is equal to 2. What do you get when you put 2 over here? So f of 2 will actually give you 4. F of 2 will actually give you 4. This is the same way of writing down this thing. You can write it down in any one of the way. So you can write it out like this or like this. Alright. Okay. So what I was saying is that both of these functions behave exactly in the same way except at the point x is equal to 2. Fx has a value 4 at x is equal to 2, or in other words f of 2 is equal to 4, whereas the function gx is not defined at x is equal to 2. We just now mentioned that g of 2 is not defined because we are having 0 at the denominator. So what changes do you think we can make? We just have to remove 2 from the domain over here. So f has the domain entire real line. What we can do, we can just restrict the domain of f, because we have just seen that apart from this point 2, the functions behave in exactly the same way. So we can transform this domain of f from r to r minus 2. That's it. And that's your answer. You just say that okay, we change the domain of r from r to r minus 2, and that's it. So this is one particular solution. Alternatively, what you can do, you can keep the domains for both the functions and r. That means you can keep the domain of g as equal to r, but what you do, you define separately that when x not equal to 2, you will be taking gx as this, and if x is equal to 2, you will take gx is equal to 4. So you see, both of the functions will then become equal because f of x is 4 at x is equal to 2, and you have defined your g in such a way that if my x is not equal to 2, I will take gx as this, and if my x is equal to 2, then I will take my gx as 4. In that case as well, your function, both of these functions will be equal. So the choice is yours. You can define the two functions in any way you want. Okay, now you're given that f is a function from real line to real line, that means real number to real numbers, and fx is given to be x squared plus 3. Find the pre-images of the following. So you have to find the pre-image of 19. So as already discussed, for finding the pre-image, what do? You just find out that value of x that gives you 19. So that gives the value of fx to be equal to 19. So on solving, we get 19 minus 3, 16. So x is equal to plus minus 4. Okay, so that means plus 4 also gives you this 19. So that means f of 4 gives you 19, and f of minus 4 also gives you 19. Okay, so what I wanted you to see over here is that it's actually a function where both of these 4 and minus 4 are going to 19. Remember that you don't have to be confused that okay, both of these points are going to the same point. How can it be a function? No, the other way around is not possible. This is possible. 2 points can go to the same image, but 1 point cannot have multiple images. Keep this thing in mind. So this is a valid function. No objections in that. So what I wanted you to know is that these 2 points, 4 and minus 4, are called the pre-images of 19, and we write them down like this: f inverse of 19 is the set minus 4 and 4. All right, so that means this is called the inverse function. So this inverse function gives you the opposite images, that means the pre-images. So if you want to find out the inverse function of f for this point 19, then you have to find out all those points that give you 19. Alright, so this brings us to the concept of inverse of a function. So if you are given a function such that it takes the value of y at some point x, and it can also take, okay, so say for example x1, and it also takes the value y at some other point x2, and it could be many more. Say for example there are 5 points. All right, so there are 5 points where the function takes the value y. Then we write f inverse of y is equal to all those points where the function gives you the value y. So you can extend it to any length. Just remember that it has to be the set of all those points that give you the point y. All right, this is the inverse of a function. Okay, so the same question again, you try it on your own. Let f be defined from R to R such that fx is equal to 1 when x is a rational number, and fx is equal to minus 1 when x is an irrational number. So what is f of half? F of half, okay, half is a rational number, right? So whenever x is a rational number, the definition of f says that whenever you take your x to be a rational number, the output is 1. So f of half is also 1, because whenever your input, that means x, is rational, your output is 1. So similarly, f of 0.34 will also be equal to 1, because 0.34 is again a rational number. But what about f of root 2? Root 2 is an irrational number, right? So f of root 2 will be equal to minus 1, because the definition says that whenever you take your x from an irrational number, it should give you output as minus 1. So f of root 2 is minus 1, and in fact f of pi is as well minus 1, because pi is an irrational number. Don't think that pi is equal to 22 by 7. This is just an approximation to pi. This is not the actual value of pi. The actual value of pi is something like 3.148 something. So this pi is actually an irrational number. All right, so pi is an irrational number, and therefore the output of this function should be minus 1. Okay, now it asks us to find out the range of f. Okay, so the range of f is all those values of f that the function can take, right? So here we see that the function f can take only two values, 1 and minus 1. So the range is 1 and minus 1, because whatever is your ordered pair is, be it half comma 1 or 0.34 comma 1 or pi comma minus 1, all the time in the right hand side will be just having 1 and minus 1 every time, because there is no other possibility. It can only take the values 1 and minus 1. So the range of a function is all those values that it can take, all the images that you can get for any value. So the range set is just 1 and minus 1 over here. What is f inverse of 1? Okay, so f inverse of 1 means all those points that will give you 1 as image. So what are those points that will give you 1 as image? That means what are those values of x which when you plug inside f will give you 1? It is clear from the very definition, right? All of the rational numbers will take you to 1, right? So that means f inverse of 1 is actually this entire set of rational numbers. And similarly, f inverse of minus 1 is the set of irrational numbers. So r minus q. Alright, that's it. So Uh, there will be one more part of the chapter functions. Till then, I request you to go through these concepts, go through the examples, solve examples in your textbook, and try to familiarize yourself with these concepts. The things quite seem to be a bit difficult, but keep on practicing. You will get the hang of stuffs. All right. Study hard, study smart. Bye bye. Thanks a lot.